In this video, I will go through question 5 from exercise 10F Mechanics 1. A box P of mass 2.5 kg rests on rough horizontal table and is attached to one end of a light inextensible string. The string passes over a small pulley fixed at the edge of the table. The other end of the string is attached to a sphere Q of mass 1.5 kg, which hangs freely below the pulley. The magnitude of the frictional force between P and the table is K Newton. The system is released from rest with the string taut. After release, Q descends a distance of 0.8 meter in 0.75 seconds. Modeling P and Q as a particle, this is already done here. Okay, calculate the acceleration. Show that the tension in the string is 10.4 Newton. Find the value of K, and B, state how in your calculation you have used the information that the string is inextensible. So I've got the diagram here. Okay, and I wrote down all the forces which acting on both particle P and Q and also on pulley. Okay, so the first part of the question, part A, it says modeling P and Q as a particle. Okay, part 1 of A, calculate the acceleration. To calculate the acceleration, okay, let's use all the informations which we've got. Let's say for Q, okay, S U V A T. So you might think why we cannot write equation for P and Q and then using like solving them simultaneously to find acceleration. The answer for that is we can form two equations, but unfortunately in this case we will have three unknowns. One obviously is acceleration, another is tension, and another one is K here, K Newton. We don't have the value for K. If we had the value for K, we didn't have to use the Silvat equation. We could write an equation for particle P, another equation for particle Q, solve them simultaneously and work out A and T. But it is not the case here. S is 0.8, as the question says. Okay, it says after release, Q descends a distance of 0.8 meter. U is 0 because it's a starting move from rest. We don't have the final velocity, which we are not even interested for that. We want to work out A, and the time taken is 0.75 seconds. So therefore, S is equals to UT at half AT squared. 0.8 is equal to 0 times 0.75 add half A 0.75 squared. So 1.6, this one becomes 0. 2 times 0.8 is 1.6 is equal to 0.75 squared A. Okay, divide both sides by 0.75 squared. You should get A equals to 2.844 and so on, meter per second squared. So therefore, the acceleration of Q is 2.84 meter per second squared. Three significant figures. Okay. For part 2, we need to work out the tension in the string. So to work out the tension, okay, so now we've got the acceleration. We can write equation for Q now. Okay, for Q, obviously the forces for Q are the vertical forces. So R downward is positive, therefore 1.5. Okay, so this is Q, this is P. I haven't labeled them. 1.5 G minus T is equal to mass times by acceleration. Acceleration is 2.84. Okay, so simplifying this, we should be able to get T equals to 1.5 G minus 1.5 times by 2.84, and finally T is equals to 10.44 Newton. So the tension in the string is 10.4 to three significant figures. Okay, newtons. Okay. Part 3. Find the value of K. Okay, to work out the value of K, all we need is just write down an equation, okay, for particle P. Okay, apply the Newton's law, Newton's second law for particle P. So it's moving in this direction, therefore T is positive. Minus K must be equals to mass times by acceleration. We already worked out T and A. Just sub the numbers in. T is 10.4 minus K equals to 2.5 times by 2.84. K is equals to 10.4 minus 7.1. So therefore K is equal to 3.3 Newton. Part B. State how in your calculation you have used the information that the string is inextensible. So, because the string is inextensible, the tension in all parts of the string is the same. And end of the question 5 now.